Hello again. Hello. Hello again, students. So, the purpose of this video is to use the fact that we know how to measure angles in radians to determine what other geometry we can do in terms of angle measure. And we'll start with what we do already know. So, previously, what do we have from the previous video? We have that the radian measure of an angle is the same thing as the arc length, s, divided by the radius. And one thing that allows you to compute just by simplifying is you could solve this first and get s is equal to theta times r. So that means if you know the angle you rotate by and you know the radius of a circle, then you know the arc length. Well, what else can we do? So let's draw a picture of another situation. So let's now actually begin reading. So suppose I give you a blueberry pie of some radius r. I don't tell you what that radius is. It's a given. And you cut out a slice of that pie corresponding to an angle of pi over 4 radians. So let's draw a picture of that. So there's your pie. It has radius r. You cut out a slice totaling pi over 4 radians. Let's figure out how big that slice of pie is. Let's compute the area of this slice of pie. Well, here's how we'll think about it. How many radians are in a full circle? Well, 2 pi, of course. So let's determine how many times this angle goes into the full pi, because that will tell us how much of the full pi this takes up. Well, that's an easy bit of division to do. I need to know how many times pi over 4 goes into 2 pi. So I need to know how many times pi over 4 goes into 2 pi. So that's 2 pi divided by pi over 4. And well, that's easy to compute. That's 2 pi. I see a fraction in the denominator, so that means I need to multiply by the reciprocal. 2 pi times 4 over pi. The pi's will cancel. And it looks like you just wind up with 8. So what does that mean? That means this slice is 1/8 of the full pi. What's the area of the full pi? Well, we know the formula for the area of a circle. A circle has area pi r squared. The area of this pi is pi times the radius squared. So if you want to know the area of this slice of the pie, well, that will be the whole area divided by the number of slices that would happen if you cut them all into slices of this size. So that'll be 2 pi. And if you were to cut the whole pie into a bunch of slices, each with this angle measure, you would cut it into 8 slices. So it'll be 2 pi divided by 8, or pi over 4. So that's how big each slice of this pie is. Now, obviously, you could do this with, there's nothing special about any of the numbers I gave you. You could do this in full generality. So suppose you have a circle of radius r, and you cut out a sector corresponding to an angle of theta radians. This region is known as a sector. So let's use the same computation. So you cut out an angle of theta radians this time, so let's draw a corresponding picture. There's this circle, you cut out an angle of theta radians. I haven't told you how big theta is, so I can't draw a correct picture. Of course, I couldn't anyway. So there's an angle of theta radians. I would like to know how much area is in this sector. Well, here's how we'll figure that out. A full circle has 2 pi radians. So let's use that to figure out how many times this sector goes into the full circle. Well, that's easy to do. That's just division, right? If you want to know how many times theta goes into 2 pi, that's just 2 pi divided by theta. There's no simplification. I don't know what theta is. It's just 2 pi divided by theta. The area of the full circle, same as before, is pi r squared. So you can compute the area of the circle by taking the whole area, the area of a sector, by taking the area of the full circle, namely pi r squared, the area of the full circle, divided by the number of sectors that you would draw if you broke the whole circle into sectors of angle theta, but that's computed right here. Pi r squared divided by 2 pi over theta. And so, well, that's a formula, but it's obviously not simplified. Let's simplify it. So that'll be pi r squared times theta divided by 2 pi. The pi's will cancel. Right? You multiply by pi and then you divide by pi. And it looks like we are just left with r squared theta over 2. There's a formula. If you start with the circle of radius r, and you draw a circle of angle theta, then the area of that sector is r squared theta over 2. Now all the stuff that we just did was the reason that that formula is correct, but the main takeaway here is remember this formula, because if you know that formula, then you can use it to make computations. That's what we'll try to do. So let's use it to make some computations. Let's suppose you draw an angle of 1 radian inside of a circle of radius 1. Then how much area is in that sector? So an angle of 1 radian, so it tells you theta equals 1. In a circle of radius 1, so that tells you that the radius is equal to 1. Then you can use this formula. The area of this sector is r squared theta over 2. So that will be, the radius is 1 squared times theta over 2. It's just 1/2. Are there any units? No. So the area is just 1/2. So a thing that I want to point out here, because it's a common stumbling block, is if the angle I give you, the radius I give you, don't have any pi's in them, then there's no pi in the answer. So just because you're doing trigonometry and doing things in terms of radians doesn't necessarily mean that there will be a pi in the answer. There might be. In this next one, we will see that there will be a pi in the answer. So let's suppose instead I give you an angle of 1 degree inside of a circle of radius 20. Then how much area is in that resulting sector? So you'll notice here that this angle isn't in radians, it's in degrees. The formula we just developed only applies if you have a circle that an angle that's measured in degrees. You would need to do some conversion to get a formula if the angle is in degrees instead of radians. So let's take that 1 degree angle and convert it into radians. So I'll do that over here. So let's see, 1 degree, well, we know how to convert from radians to degrees. That's 1 times pi over 180 radians, or just pi over 180. So there's the angle theta inside of a circle of radius 20. So that tells me that the radius is 20. That's everything I need to compute the area. Area is r squared times theta over 2. The area is r squared, so that's 20 squared times theta, pi over 180. all over 2. And that obviously should be simplified, and I've got the time to simplify it. If you want to pause the video and do it on your own, go for it. But let's proceed. So, 20 squared, that's 20 times 20. 2 times 2 is 4, so that'll be 400. I multiply by pi, then I divide by 180, then I divide by 2. So that'll be the same thing as multiplying by pi and dividing by 2 times 180. Now on the one hand, you can see that like 2 times 18 is 36, so 2 times 180 is 360. But I'll want to try to make things easy for me to cancel. So I only see multiplication in the numerator, I only see multiplication in the denominator. So maybe I should try to factor some common factors out so I can cancel them. So in that 400, I certainly see 4 times 100. So 4 times 10 times 10 times pi. All over, let's look in that denominator. That's 2. 180, I certainly see 10 times 18. 18 is 2 times 9. So there it is after some factoring. Let's check out some things that cancel. Well, this 4 is 2 times 2, so that 4 will cancel with these two 2's. I see a 10 in the numerator and a 10 in the denominator, so since all of these are multiplied, those will cancel. And I don't see any more common factors to do anything to. So that'll give me 10 times pi over 9. So there's the area of this sector when you make an angle of 1 degree inside of a circle of radius 20 centimeters. 20 units? No units. Cool. So now that we've done that, the next... Well, you know what? Actually, I think that it's reasonable to break this into 3 videos. So there's going to be a third topic that I'll hit in just a moment, which will be angular and linear velocity of rotating gears. So I'll stop this, and we'll be back.